Hello, everyone. My usual first question, can you hear us and see us? If you can just use the chat. Okay, thank you, Anton, Marwan, thank you. Okay, so it's a pleasure to have another Stark at Home. And this time, the focus is going to be on a magnificent project called Warp. And we have the creators of the Warp project with us, and let's focus the screen on them. I'll just introduce, first of all, with me to lead the interview is going to be Shahar Papini, who's on, if you have the same screen on the left, Cairo co-creator from Starkware. And now I'm going to focus on our main main people in the event. So we have Greg Vardy, CTO of Nethermind as of 2 days ago, I think, and Yorick Schillikens of the Warp Project and at Nethermind and many other things. And the essence is going to be about Warp, and we'll hear all about it. Just before that, I just want to mention that if you have a question, the chat isn't so good, so you better use the Ask a Question button. There's already 7 questions. Slava wrote a question, I think it's in Russian, so if someone can translate it as a comment, and there's another one. Anton wrote 2 questions in, unfortunately, we don't have Russian speakers among us here, so please limit the questions to English so we can all address them. If you have a question, put it there, and we'll answer it there. So maybe let's start off just with Greg and Yorick. Do you want to just give a brief introduction and then tell us what is Warp all about?
Cool. Yeah. So Warp is obviously a Solidity to Cairo transpiler. It didn't start out that way, though. I'll just give a bit of a history about Warp. So our first approach was to try take EVM bytecode, like, the opcodes, and transpile them to Cairo. It turned out this was extremely inefficient, and there's a bunch of reasons, like mostly because even the really simple Solidity contract can generate a ton of bytecode, and so we're generating like very, very large Cairo contracts. And then we took the next best approach after that to, the approach that led us to result quickest, which was going with Yule. So Yule is Solidity's intermediate representation, and an intermediate representation is just sort of like a lower level representation of Solidity, and the efficiency gains are pretty good from that, and we managed to get it finished like fairly quickly after doing the first approach. And now Warp 2.0, which has just been made public but still isn't production ready, that works by transpiling Solidity directly to Cairo, and it's a lot better in pretty much every dimension.
I now realize that maybe I jumped a bit too fast. So all of us all 4 of us know what Cairo, Starknet, and this and that are, but I think I jumped too fast in. So maybe I'm going to ask Shachar, do you want to just give maybe just an introduction into what Stark and Cairo and Starknet is, and why would anyone want even a transpiler or something like that? And then, lead the discussion from there, please.
Sure. Well, Starks is a proof system that we use at Starkware to help scale the blockchain. This is the main use we have for it. And currently, we use it in Starknet. Starknet is a layer 2 blockchain that we have. It runs Cairo. Cairo is programming language, which is meant for Starknet. And it basically produces very efficient, very short proofs of a lot of transactions of Starknet. And it posts them on Ethereum. So basically, it's supposed to get the security of Ethereum while getting a scaling and efficiency of a regular computer, my home computer or big computers, and not be bound by Ethereum. So a bit more on how Starknet works. It runs a Cairo virtual machine bytecode, unlike Ethereum, which runs EVM bytecode. So it's a different architecture. And the problem with that is that a lot of developers today are very used to Solidity, which compiles to and learning a new language might sometimes be a barrier. Now, I do want to point that programming in Cairo sometimes might be beneficial, but if these programmers that are very used to Solidity will have a better way to take their current Solidity contracts and compile them to Cairo and just run them on Starknet and get the scaling benefits, this would be very nice. And this is exactly what we are going to talk about. With this enough, Ellie? Ellie is on mute.
Yeah. So why don't you start peppering Greg and Yorick with some questions about Warp?
Yeah, sure. Okay. So can you describe? Okay, the task is to take this Solidity code that everybody's used to and produce Cairo code. Now, can you describe what your initial approach for this was, and maybe if you did it, how successful was it, and properties about it?
Yeah. So the initial approach was probably the easiest way to get this done, and that was to take the Solidity and use the Solidity compiler to turn it into EVM bytecode. And then basically, so EVM bytecode is just a set of instructions. There's a bunch of different opcodes. And so basically, we would implement each opcode as a function in Cairo. And then we'd also have to maintain like the EVM stack, because the EVM is stack-based, and EVM memory. This approach is pretty easy because there aren't that many opcodes for the EVM, and the EVM is a very, very simple architecture. So it meant we could sort of get something out the door as quickly as possible. And it turned out that it was very, very inefficient because you have to maintain a stack in Cairo, you have to simulate EVM memory. Everything is like call data encoded, which is basically means, for those who don't know, is when you send a transaction on the Ethereum network, you ABI encode the input to the function or the smart contract you want to call. And then on the other side, in the contract, it has to decode this input, and it has to do a lot of like bitwise operations, which are quite expensive. And like pretty much probably the main thing was that like an ERC20 Solidity contract, which is a token standard, it can produce like 10,000 opcodes, 11,000 opcodes, depending on how it's implemented. And so you end up getting like a lot of Cairo, and the contracts become pretty large pretty quickly. So that approach didn't really work. We had a working prototype, but they were very, very, very inefficient, like pretty massive overhead, like 1,000x versus handwritten Cairo.
Okay, and you mentioned that this approach might be inefficient, you just said, but it was quick to write. I mean, how quick was it? Like,
I think we got it done in the bytecode approach 2 months, 2.5 months, I think.
Okay.
Yeah.
So in 2 months, you had like a working version that you could take Solidity contracts and compile them to very inefficient contracts, but working contracts.
Yeah. So the problem, the reason that we weren't able to figure it out, well, definitively say earlier, is because if you want to do this method on any sort of non-trivial Solidity contract, you basically need to support all the opcodes, right? And once you support all the opcodes, you just can support any Solidity contract. Otherwise, we would have figured out earlier, because when you hit the point where you can run like a contract that actually does something, because of how simple the EVM is, it means you pretty much have all the opcodes implemented, so you can handle almost anything basically.
Okay. Okay, you guys realized that this approach was inefficient. So what was the next step?
Yeah, so the next thing was we had to. Do you want to mention it?
Yeah, sure.
Yeah.
The next thing we attempted was going through an intermediate language, which is being developed by Solidity. It's called Yule. And the idea is that could be used by various implementations to run Solidity code, but it's slightly easier to work with than the EVM code. You can still put your own optimizations on it and so on. The reason it's useful for us is because it already did a lot of things that Solidity has in semantics. So it handled imports, and it did a bunch of optimizations on basic arithmetic operations and branching. And then the final language is quite simple, so it's easy to encode in Cairo, and it's actually quite close to Cairo in a lot of ways. It's easy to work with. So we then built the transpiler for Yule. So it basically goes Solidity, and then we point the source C compiler at that, point at Yule, and then we just wrote from Yule to Cairo. And this was actually quite good. It also went quite fast at implementation, and it was also quite handy that we had the implementations for the opcodes, I think.
Yeah, because Yule, in Yule, so there's only one type apart from string literals, and that's the U-256. And the EVM, it's the same. There's only one type, U-256. And a lot of the Yule built-in functions, they're just EVM opcode functions, and we had all of those implemented already.
So we could just call out to those whenever we needed. So we'd already gotten a bunch of work done from the first place. But this actually also turned out to be quite inefficient, even though it did work, and was compiling quite large contracts, but not as large as we would have liked. And most of those inefficiencies come from two areas. One is that the U-256 operations are quite slow because Cairo's data type is a felt, and U-256 is larger than a felt. And bitwise operations, multiplication, require more steps than your normal architecture would take. And then the other major inefficiency is that we still rely on the call data semantics, which is this encoding and transcoding that's required for the function calls. And it turns out that if you get rid of that, you can get a lot of optimizations out of it. So we were still wrestling with this, and it's just a fundamental part of this approach that makes it inefficient, which led us on to what we're currently working on.
Yeah.
Okay, just a few questions about this approach. Okay, so yeah, like you said, it probably still has efficiency problems, but was it better than the previous approach?
Yeah, much better, because we didn't have to maintain an EVM stack anymore, because Yule doesn't expose that directly.
Okay, and by the way, can you tell me a thing about how the Warp team developed throughout these stages? Did it remain the same? Did more people work on it?
Yeah, so we've gradually had more and more people joining since we first started, I think in June. It was just, I think it was 3 of us in the beginning, and now there's about 9, including interns. So yeah, it's gotten a lot bigger, but also because the current approach with Warp 2.0 is a lot more complex than the Yule and bytecode approaches.
I'd like to ask. I'm going to be the one in charge of asking the dumb questions. So you mentioned something about EVM being U-256, and then you need to move it to something that you said a felt or something. So I'm guessing it's not the cloth. But can you maybe explain what do you mean, and why is there? What's the issue here?
The felt is the fundamental data type of Cairo. It is a large prime over which we have a set of operations that we can construct our proofs.
Well, the felt is an integer over a large prime field, right?
Yes, yeah. It's technically a restriction of that range. U-256 is too big. I think the felt, I'm really bad at remembering numbers off the top of my head, but it's 128, right?
Yeah.
Cool. So to represent a 256-bit integer, oh no, it's large, right? No, we split into 128 ranges to fit them into both, but it's 240.
Yeah. So yeah, basically, because the felt, if you're talking about positive and integers, which is positive and negative numbers, we can't do 256 bits in the felt because you'll get an overflow. So what you need to do is you need to create a structure that holds 2 felts that represents the high and the low bits of the U-256. And so now every operation on that UN256, that structure, because it's got two elements, everything is at least twice as slow.
So now I realize I have another dumb question, but this time I think it's to the Cairo code creator. Why did you pick this weird data type of a felt and not work like everyone else with a 256-bit integers or something like that? Why is that?
Yeah, that is a good question. I mean, this is a corollary of a main decision we made when developing Cairo. We could have made Cairo very compatible, maybe even EVM compatible, like a ZK EVM. The problem is it wouldn't be as efficient for the proof system. Proof systems like Starks are based on polynomials over finite fields. And thus, using a basic type of field element gives a much more efficient polynomial equations, and this make also the proving time better and the verification time. Uh, so a lot of the choices of Cairo, including using field element, were done for efficiency's sake, like the immutable memory, no for loops included, and a lot of other stuff. So yeah, it sounds. I have a question for Greg. It sounds to me like there is like an underlying issue here, that there is a difference between the basic data type in Cairo and basic data type in EVM. EVM, they use U256. In Cairo, we use field elements. And like you mentioned, the solution you started at the beginning was uh, simulating this UN256 operations inside the Cairo as field elements, as you break it into a few field elements and do something that is a bit more expensive than native computations of field elements. This sounds to me like something that is inherent, like a fundamental part of the problem here. How can you get over this problem?
Yeah. So the way you really get over it is to have if you go up. So we go up a level from the EVM into UL, and that doesn't get rid of the UN256 problem. But what it does allow us to do is because UL is high level, we can have like more semantic context about like where we are, let's say in a UL function, or like are we in a for loop or something. So it's a bit easier to write more efficient code in that case. But then when we go up a level again to Solidity, we have like the full range of integers from like uint 8 all the way up to, and int 8 all the way up to 256 in steps of 8. So now there's like a whole bunch of types that people can use for their integer types. And yeah, sure, if someone does use a U256 in Solidity, it's going to be just as slow as in the Yule approach. But because in the Yule approach, everything gets serialized down into a U256, so they end up being like an order or two of magnitude more of these U256s.
I realized that I have another dumb question. I hope it's not detracting. So let me know if it does. And everyone's talking about this ZK EVM, and first of all I want to understand: is Cairo a ZK EVM? Is Warp a ZK EVM? Is what I mean? What is a ZK EVM, and is this it, or where does it map?
Yes. So obviously Cairo isn't a ZK EVM, but the ZK EVM is just like an implementation of the EVM that is amenable to zero knowledge proofs. So I think they're right. Like, well, there's no open source implementation yet. I think, well, there isn't. So like a lot of the ZK EVM rollups, the implementations aren't open source, so it's sort of really difficult to know how they're actually doing it. But yeah, so that is different because Cairo has its own virtual machine, which I think obviously Shahar can talk about.
But then I'm confused, because if Warp takes code that is designed for the EVM, and somehow magically makes proofs for it. Well, not ZK proofs, but people call them ZK proofs, but they're validity proofs anyways. So isn't this, is this a competing approach? Is it the same thing? Is it like, how does, why isn't this not ZK EVM, or where does that fall? Like, where does Warp?
Yeah, I think if you look at it at like a really high level, you could say that it's making Starknet EVM compatible if people are only writing Solidity, I guess, which 99% of people do only anyway. So in that sense, yeah, if you don't want to be too like pedantic about the definition of it, then you could call it that, I guess. But yeah, the main difference is that the ZK EVM is running the Solidity. We're not running the Solidity. We're taking the Solidity and turning it into Cairo and then running the Cairo. Right? But to a high-level user, they would still just be writing Solidity in both cases. So to them, there's virtually no difference.
Yeah, I want to add a few words here as well. Yeah, I'd say there are two approaches here. One that might be called ZK EVM is taking the EVM semantics and implementing them as the polynomial equations of the proof system, whether it's Stark or something else. So really doing it as the virtual machine of the underlying L2 or blockchain or whatever. So another approach is not to take the EVM semantics and make polynomials of them. The approach that we took is compiling it to Cairo and having polynomial equations just for Cairo. Now, there is a question of like what is better, or why do one or the other. So I want to okay, if you know that everything you need to do is EVM, then maybe a ZK EVM would be better, but not always. I'll give an example. Assume you have a Solidity contract, and it doesn't really use a lot of the EVM native things, a lot of Ketchup, a lot of uint 256. Maybe has some simple logic that can be translated very nicely to Cairo. In this case, using Warp might create a Cairo contract, which is a lot more efficient to run on Starknet than if it was in ZK EVM. Because, for example, if you only use uint 8, uint 32s, something like that, then it could be the case that just more efficient because Cairo is efficient and you use a simple logic. Now, the downside of this approach, however, is that everything is not fully EVM compatible in the sense that taking the state of Ethereum right now and with all the EVM bytecode that is in every contract, all the data there, and you can't just plug it into Starknet. There needs to be some translation. So it's not fully compatible with EVM Ethereum as it is today. It requires some translation there.
Yeah, I think those are some really good points. And like further to that point is like the EVM wasn't designed originally with this in mind, right? To be zero knowledge compatible or runtime. And so when you're trying to take that and push it into like a different shape, it can be much, much more difficult. Whereas if you have Cairo, you can start from scratch and say, let's build the best possible like validity runtime, validity proof runtime. And so you're not necessarily constrained by a bunch of like historical semantics that were defined without taking this into consideration. So it opens up like a lot of doors, like with built-ins and some of the really cool things in Cairo. Yeah.
Sorry for detracting it to like this question, but Shachar, Greg, Yorick, if you want to continue on, with the line of questioning. Also, at some point, Shachar, when you feel comfortable, maybe we should go to the ask a question, or when Greg and Yorick think it's a good time. I'll leave it to you. Sorry.
Yeah, I think we can go on to the next questions if you're okay with it. Um, can you describe what were the main challenges you encountered while in development, in programming, also in efficiency, and how you overcame them?
Well, are you interested in the old approaches or the current one that we're?
Well, let's talk about Warp 2.0.
Yeah, okay. So Warp 2.0 is the new approach, which is intended to be more efficient and basically produces Cairo code that's much closer to the original Solidity. This works really well because it reads very much like the original Solidity contracts.
What were like the challenges?
Yeah, so the challenges to this are there's a bit of a mismatch between Solidity semantics and between Cairo semantics. That's mostly inherent in the immutable data that's in Cairo. While Solidity is mutable, so we can pass around references to arrays, update values, but in Cairo we can't do that. And our only way to approach this is to try and build a memory model in immutable memory, which we can like update piecewise with the updates that are expected on the Solidity side, and then collapse them all together at the end. And for that, we've had to write basically an entire abstraction for all of the data types in Solidity, and also write an abstraction for how they were represented in storage in like layer 1 storage, and come up with this framework that was general enough to handle all the cases, but not so specific that it was annoying to work with. So that was one of the biggest challenges that is being finished like more or less this week or next week. Dom Henderson's done a lot of the work on that, and it's coming together very nicely, which is great. The other thing is representing types, Solidity types in Cairo. The question is, how do you encode each of the basic Solidity types? And that needed some planning at the start. But after that, this project has actually been quite smooth sailing, and Warp 2.0 is coming together quite quickly.
Yeah. So just to take you through like a basic flow of how Warp 2.0 works. So what happens is we use a library to get the AST of Solidity, and I'll explain what that is. It's an abstract syntax tree, and it's like a structured representation of the Solidity program, right? That makes it easy to traverse it's this tree structure that it's nice to traverse and do transformations on, etc., etc. So we take this Solidity AST, and then we do like a bunch of transformations on it that make it easier to generate Cairo. So one example is we'll turn for loops into functions. We'll also turn like some if statements into functions to prevent reference revoking in Cairo. What are some of the other ones we do? We do like constant folding, like some small optimizations. So it's just a bunch of these steps, right?
We need to replace all the arithmetic with the correct calls to Cairo functions because they're not like native Cairo.
And then at the end of this, we have a Solidity AST that's much easier now to generate Cairo from. And so we go through it, each AST node, and we generate the corresponding Cairo, basically.
And luckily, it's so close to Cairo that writing is very simple, which allowed us to have a working prototype within a couple of days when we started.
Nice. And this new approach, how efficient is it?
Yeah, we actually have some slides on that, which we can share with you now. Oops, wrong one. It was where? Yeah. There you go. Yeah. So yeah,
it's also on the screen. So.
Yeah, no, it's reversed there. So this is Warp 2.0 versus 1.0. There we go. And as you can see, Warp, well, this is the Yule version of Warp, and it's pretty much not even on the graph. This is how. So the blue lines are the number of steps in Cairo. So this is like generally how we think about efficiency in Cairo is through like step count. And so as you can see, the blue line is before, which is the old version of Warp, and the new one, the orange, is the Warp 2.0, and it's pretty much orders of magnitude more efficient in like every single way you can measure it. There we go. Oh wait, no, you skipped one. Yes, and so this is an example of MakerDAO. So MakerDAO has written a DAI implementation in Cairo. Someone said they lost audio and video. Can you guys hear us? Oh, no. Yeah, no, he's saying it works for him. Yeah, so as you can see, it's pretty much, so the blue line is we took the MakerDAO's Solidity implementation of DAI and we transpiled it to Cairo, and then we compared it with their handwritten version of the DAI Cairo contract. And it's pretty much the same, like no major differences for all the standard ERC20 functions. And so the next slide is an example of what Warp, So this is how ugly the Cairo used to look for the Yule approach of Warp. It's pretty unreadable. There's a lot of weird function names that get injected from Yule that gets.
Well, maybe you should increase the font size, because I think at this size,
it's purposely done like that. It's kind of on purpose to show you how.
Okay.
Because you'll see the next one now. Yeah. So this is the.
Yeah, that's cheating, because now with you increase. This is the unreadable one, because the font now is bigger. Or this is the new one.
This is the one that's much more. So those two are the same functions. You can see the other function was like 10x is longer, and was that one relative to Warp 2.0, which is much easier to read. You just sort of we'll have some documentation about how to read it. But one of the great parts about this is it makes your Cairo code a lot easier to audit and reason about. And obviously. The Warp Yule version is pretty much unreadable, so that's one of the major pluses apart from the massive efficiency gains.
I just want to mention that we have a Cairo VS Code extension that does syntax editing, so you know.
Yeah, my bad. Cool.
But by the way, reminding you, maybe it's when you feel comfortable, maybe we should go into a few of there's quite a few questions. So when do you think would be a good point to jump over and see a few?
We can have a peek at some of them now, I guess.
Yeah.
Okay. Wait, let me just make myself small. I want to make you guys bigger. And then okay. Shachal, do you want to lead through the questions, or do you want me to read them, or
You can read the questions, yeah.
I will read the questions. So question number one, it's a pretty long one. Is it or will it be possible for us to opt in to tell the compiler to just consider all our UNT 256s as UNT 252 instead, which is what would fit inside a felt, I believe, in order to avoid these performance issues you were mentioning? I imagine a lot of scenarios, token contracts, where those extra bits can be easily discarded.
Yeah, so you'd probably just use a UNT 248 in Solidity, which would then be fit into a felt. So you would just write the Solidity type to be whatever type you wanted it to be, and then the Warp would handle the rest. So yeah, adding a whole nother type to Solidity would mean that we would have to change the compiler, Solidity compiler a bit more, and it's like a bit of a maintenance cost. But if lots of people want it, we might consider it.
Also, I want to mention that UNT 248 won't be good enough. Neither will 128. You actually need to go down to something like 124, I believe. Otherwise, things would still be inefficient, because you need to be able to multiply two numbers and not get an overflow. So maybe down to 124.
Okay. Next question is, how did the idea for the project come about? Anton is asking.
Yeah, so it was, I think, Tomasz, the CEO of Nethermind, was in contact with Yuri about this, and they asked Nethermind if it was something that we could do, and Tomasz said, yeah, sure. And so we got an initial sort of prototype and sketch by the STRK guys, you guys, of what the bytecode transpiler might look like. And I saw Yuri do a tweet saying something like, hey, we're looking for people to work on a transpiler. And so I DM'd him, and that's sort of how I got involved in the project, which was pretty early on.
Okay. Next question: in what levels do you expect developers will use the warp? I'm not sure I understood the question, but I'm asking. I guess in what levels do you expect developers will use warp?
I can take a stab at trying to interpret what that means, but we had basically two use cases in mind, especially with Warp 1.0. The idea was to demonstrate the capabilities of Starknet by allowing you to just translate your basic contracts and see how they would, just show that they would work on Starknet. And Warp 2.0 is going to become a lot closer to an actual usable language. And in that sense, you could write code for Starknet starting from Solidity and having that work for you.
Yeah. So like
professional tool.
Yeah, and also like if you have, let's say you're a protocol, right, and you have like a big complicated Solidity code base and you've invested a lot of resources and get, people learning Solidity, everyone knows how it works really well, it's easy to extend, and you don't really have the resources to, for some reason, for your developers to learn Cairo, and so you could just go to your command line, type warp transpile with the name of your contracts, and then warp deploy, and then your contracts are in Starknet, on Starknet. And so Warp 2.0 should pretty much be able to handle almost anything apart from like a few things that aren't implemented on Starknet yet.
So let's take the last question for now, and then we'll get back to more questions. So this question says, it's two questions. One, to what extent does transpiling Solidity to Cairo expose new security loopholes? And two, how succinct is the transpiled Cairo code? Are people expected to start working with the transpiled code at some point, or are they expected to continue editing in Solidity? So one is a question about security loopholes, and the other is, what is the, do you transpile and then go and work in Cairo, or do you keep working in Solidity?
Do you want to mention the semantic tests?
Yeah. So in terms of security loopholes, one of the big things when it comes to transpilers is that your understanding of the semantics of the original language and how it's encoded in the target language don't actually line up with the reality of the situation. This can show up anywhere across the stack, from implementations of EVM all the way up to transpilers and so on. To try and fend this off, you can formally write a definition of the language, which we have started partially. I don't know if the project is going to continue, but it's a specification of Vue and a specification of Solidity in Lean. And then in a more sort of direct engineering style solution, there are a whole set of semantic tests, about 1,200 of them, that Solidity has implemented for their implementation of the Solidity compiler. And we've been able to take these tests, translate their inputs, the correct inputs for the Yule approach, this Warp 1.0, and for the current approach in Warp 2.0, and run all of their tests against our transpiled versions. So we can try and guarantee that the semantics of the first are upheld in the second.
So the Solidity compiler, as you said, it has these over 1,000 semantic tests, and it's just code written in Solidity, and then you have some function calls that test almost all of the semantics of Solidity and some expected outputs and results of those function calls are executing certain Solidity code. And so we take all those contracts and all those tests and we transpile them to Cairo, and then we execute them on the Cairo VM and check that the outputs and the expected results are the same as the ones that were defined in the original tests. So those tests cover pretty much all of the Solidity semantics, well, as reasonably possible, right? And so when we have all of those passing, we're pretty confident that it's semantics preserving. So yeah, on the security front, there's that. And what was the second question again?
Okay, our developers, what's going to be the mode of operation? I just keep on writing only in Solidity, and I don't need to know anything about Cairo, or is it like this one, I first write it, get it in Cairo, and then I move over and continue in Cairo? How is it going to work?
Yeah, so with Warp 2.0, you have either choice. you can use Warp to transpile some of your contracts to Cairo, and then you can write Cairo native Cairo for the rest. Or you can just write Solidity and transpile your Solidity contracts. And if you want to make a change, you just go change the Solidity contract. But that's the nice thing about Warp 2.0 is it will be readable, the generated Cairo. So you will be able to just generate some Cairo from some of your Solidity contracts, and then you may want to handwrite the rest of the Cairo.
Okay.
So,
To add, like my view here is, as long as you are doing simple things, and if you're very familiar with Solidity, then using Solidity is okay. But I think the end goal should be maybe to use Cairo maybe for the efficient part, the part that don't translate well, and maybe for better interaction with other Starknet contracts which are written in Cairo to be easier integrating.
Yeah. If you're a new project starting from scratch, it's better to go with Cairo straight away. Yeah.
Shachar, do you want to continue asking questions or?
Yeah, let's see. Yeah. Okay. So there was the initial version that used bytecode, compiled straight from EVM bytecode. The second version compiled from Yule. The third version is compiling from Solidity. Is there anywhere to improve? Do you have any thoughts about in the future? What can be more efficient? What you want to do? Things like that.
With Solidity, with Warp 2, it's a fundamentally different approach to the previous ones, and I don't think there's much more space to do that big fundamental jump. So most of Warp 2 will just be optimized. We'll realize that we can drop certain operations or change a pass in such a way that we produce less code, and that work will continue as the project is maintained. In my opinion, the biggest jumps that you can make is to try and either restrict Solidity in certain ways or create your own higher level language to work with. And I know that there are certain projects that are looking into that. So I think that would be a huge thing. But I think we have cut out as much as is possible to cut out of Solidity while preserving the semantics exactly.
Yeah. So it's quite difficult to do better than Warp 2.0. There may be like small incremental improvements, but yeah, it's pretty good as it is. It's really difficult to do better for a transpiler.
Yeah, I saw that the numbers are very similar to native Cairo, as you showed in your graphs. But what about doing better than native Cairo? I mean, theoretically, there are optimizations that are possible that native Cairo does not know how to do. Inlining, things like that. You already do constant unfolding, as I heard. So maybe more optimization in this direction. You do more better than the native. Did you think about things in this direction?
Right now, the push has been towards implementing the solution, but we have considered a few optimizations in the previous version, in Mule 1, in Warp 1, in order to get it faster. And I think there are a few avenues to go down there. Yeah. I'm not actually versed on the specifics right now. So, the constant folding was an idea. Cairo's efficiency does depend on just how much code there is to execute. So anything like dead branch removals, or like dead code removal, or any branching optimizations that we can make, those would definitely be very useful. But those things need to wait until we have full implementation.
Do you want to get your charger quickly?
Yeah.
Sorry, Yorick's just going to get his charger for his laptop.
Sure. Yeah, I mean, these were my questions. Maybe you can take more questions from the audience.
Yeah, and we'll take more questions from the audience. And at some point, I think it would be, were you planning maybe to show us how something transpiled, or like what are the steps? Did you think of, do you have something like this up your sleeve?
We don't have a live demo, but there will be some examples on the repo the Warp repo, which has the Warp 2.0 as a branch on it. So the branch on the public Warp repo of Warp 2.0 is called Warp/TS. TS is just for TypeScript because it's written in TypeScript. And so we'll put out like a bunch of examples there, like transpiling die, ERC20s, etc., etc.
Okay, let's take a few more questions. Miguel asking, do you support code that relies on things such as gas left and other EVM specific features?
No. Yeah. So there's things like that don't yet make sense on Starknet, like gas left, block difficulty, base fee, those sorts of like ETH specific operations.
Okay, another question. Yoav is asking, what are the limitations? What kind of Solidity programs can't be transpiled to Cairo? Or maybe can't be transpiled there are like two questions hiding here. Cannot, period. I don't know what that means. Like, what something explodes. But there's also, transpiles, but like this is just completely horrendous.
There are two main things that will not be supported by this. One is try-catch. Basically, the reverting semantics on Cairo would be a real pain to encode them in Cairo, basically, and it's almost impossible without actual support from Cairo. This is, not to be supported for the time being. The other thing that I struggle a bit with is it works perfectly fine in Warp 1.0, and if you need this absolutely desperately, you can go towards that. But that's inline assembly, which is a big thing for fallback functions and proxy patterns and so on, which allows you to write YUL in the Solidity code in order to use lower level operations. But we do have a solution to this, which is that we're going to support inline Cairo in the long term, which will allow you to call low-level Cairo operations, which will do very similar things. The translations are usually quite simple between the two, so it's actually not that big an overhead to just go through your contracts, find where you're using inline assembly, and replace it through Cairo.
Yeah, because we've already got all the YUL functions implemented as Cairo library functions. So it'd be pretty simple to translate between the two. And there's quite an important reason as to why we don't want YUL written in Solidity contracts. And because the second we allow that, we're again exposing EVM semantics, and we have to ABI encode call data and ABI decode call data. And that's pretty inefficient. It just adds some inefficiencies. And then you have to, maintain EVM memory again, because YUL can have mstore and mload, those operations. And so it just adds a whole bunch of overhead, and it's not really worth it.
Okay. Next question. Just 1 second. Where is it? Okay. Commenting on the recommendation of using UNT 124. There's no UNT 124 in Solidity. I assume UNT 120 should be the one to use and guarantee no overflow.
Yes.
Yes.
120, 124.
It's not 120.
It's just divided by 8.
Oh, yeah.
Okay. Another question by Walid. Solidity uses a different elliptic curve than the one in Cairo. Does the transpiler convert the logic in any way to Cairo's native curve or not?
No. Are you talking? Is he talking about the EC recover opcodes, the precompiles in Solidity?
Yes, I assume it does.
Yeah, so we don't support precompiles either. And so basically, if you're transpiling existing code, in our README, we'll list all of this stuff. It'll all be there. So you can just have a little checklist, and you can just do a quick skim of your existing code to see if there's anything there that you'll need to change.
Yeah, but I assume that from a correctness point of view, these calls for precompiled contracts could be just replaced with calls to regular contracts that will implement those things. And we do have some Cairo implementations for elliptic curve operations in other curves and fields. So it should be not hard to implement one.
Okay. Another question: is there similar work being done on transpiling WASM to Cairo?
Not that I know
No, no.
Okay.
of. But I'm accepting pull requests if you want.
I will say this. Just as now speaking on behalf of STRK, just as we were very happy to support the Warp project, if there is a serious contender for writing a WASM to a Cairo compiler, that would also be great. Which contracts are written in WASM? I think it's some other blockchains, right? But still, that would be also terrific.
Yeah, I think there are Solana or something.
Yeah, that would be great. Like, and then you can take like Solana contracts and the logic there and make them. Yeah. So if someone out there wants to work on a WASM to, or let's make it more general. If you want to work on an X to Cairo transpiler, you fill in X for anything of interest, and you're serious about it. We'd love to support that for sure. As long as it's not, let's say, Cairo to Cairo or something like easy. That okay. Another question. I just want to pause and ask, like, Greg and Yorick, do you want to? Is there other stuff that you want to present and discuss, or should we continue with the questions? There are a lot of good questions. So
yeah, we can just continue with the questions.
Okay. So how do you guarantee that the generated Cairo is a true representation of the original Solidity? I like this question. It's a good one.
Well, that's you could ask the same question as how do you guarantee that the generated EVM bytecode is a true representation of the original Solidity? And the word guarantee is like a strong word, so you would need to formally verify this whole process. So not even the Solidity compiler has this, like, when I say guarantee, I mean like, some sort of proof, formal proof, using a proof assistant or something like that. So there, even for, the Solidity compiler itself, there's no guarantee, but you can do a whole bunch of tests and test all the lowest level operations and all the different kind of semantics, thousands of them, and you can be pretty, safe in assuming that it is the correct representation. What do you think?
As close as Solidity is getting.
Yeah, as close as the Solidity compiler is getting to taking the original Solidity and the bytecode representation, representing it correctly. That's as close as we aim to get, or we'll get to.
Yeah, I was just thinking, like philosophically or mathematically, the question of what the true representation, true meaning is in like these two models. You probably want to formally define what that means, and it sounds to me quite tricky. Next question: do you introduce additional risks when transpiling from Solidity to the Cairo VM instead of using a ZK EVM? I see. So, like, in terms of risk, I just want to say there is no ZK EVM right now, so it's hard to compare. But okay, assuming under some interpretation of what a ZK EVM is it inherently, is one approach inherently more risky than the other?
I think it's almost impossible to answer correctly without almost making something up when you're talking.
Yeah.
You know what I mean? Like if someone gave an answer to that, they'd probably be making it up, I think, or just taking a wild guess. So yeah, I can't really say for sure.
Why? Because you're saying it's not clear what. Oh, sorry, Shafar, go ahead. Yeah.
I just want to say that one process I think is writing the Warp compiler, which is written in Python. And what is it written?
Version 1 is in Python. Version 2 is in TypeScript.
In TypeScript. So you can try to you need either to trust this TypeScript code or trust polynomials for the KVM, whichever you can read better.
Yeah, that's true. Very true. Yeah, the TypeScript is a lot easier to read.
These questions get grislier. If you read anything like untrusted and trust, then you realize you have to trust the entire system from top to bottom. And it gets a very complicated question to answer. But I guess the hand wavy one is both of them come with their own set of risks. And we trust that Cairo is correctly implemented. You trust that we've written our compilers correctly. You trust someone else that their EVM is correctly implemented. So, but there's a lot of work in auditing and in testing that is going on. And we are testing in ways that are a lot better than most, in my humble opinion, and quite thoroughly. And it will be fully audited by the time it's released.
So there's another question here. I guess I want to throw, I just thought, I want to throw a question that just occurred to me. If I'm enthusiastic about this, like, is there any way I can help? Like what can I, first of all, if you can maybe post a link in the chat, like what should I, suppose I got, I want to use this or help out or build something. Maybe I know how to work with compilers or programming languages. What could I do?
Yeah, Yarek is about to post a link now in the chat to the branch of Warp 2.0. And if you go to the README of that GitHub page, all the way at the bottom, there's a link to our Notion that has like a bunch of tasks that we're currently working on and tasks that need to be worked on. So if you're interested in contributing, you can even DM me on Twitter if you have some questions about how to contribute or where we might need help, or have a look at the Notion. We're open to anyone contributing, really.
Okay. So sorry, I just made it into a call to action button. The next question, I'm not sure I understand what it is, but if you can answer it anyways. Okay, what projects are priority?
Projects?
Not to say pass or I don't understand.
Yeah, we don't understand.
Yeah, for sure.
Okay, this is a really nice question. I like this. Where do you see yourself in 1 year? And I guess I interpret it as, in 1 year, if all the stars align themselves, what do you see? What's happening with Warp in terms of usage? What's development and so on?
We just hope that it's been, it's helped a lot of protocols that would have not otherwise deployed on Starknet deploy on Starknet. I think that's the reason we exist, right? Is that to lower the barrier to entry, because I think we're all big believers in Starknet. We think it's amazing technology, and we want to do everything we can to reduce the friction of allowing protocols to get onto it, basically.
And the typical, let's say 1 year from now, and the typical, this is like the bridge that will help me bring over my smart contracts from Ethereum that were written in Solidity, or this is for a new developer, for like big established projects. Who's going to be using Warp 1 year forward?
Oof.
Well, if you get to choose, right?
If we get to choose, yeah, all the biggest protocols in Ethereum.
Yeah, every protocol uses. I really am hoping that Warp will get so close to efficient that you could write, because you have to engage with a lot of the problems that Warp solves, even if you're writing Cairo code, like how do you handle mutable memory or store references to things. And if you just want to avoid that, you could definitely write in Solidity and then just go through Warp and use all the semantics that you're familiar with. And I'm hoping that in 1 year's time, we're so close to handwritten Cairo that it's a bit of a no-brainer to choose that if you're doing something pretty small and you don't care that much about the efficiency, or you just want to see what your project would look like. So,
yeah. We want it to be completely seamless, like you feeling like you don't really need to know what the Cairo virtual machine is. You can just click warp transpile, warp deploy. Simple stuff.
And then if you're really counting pennies, you can go to the Cairo side and fix it.
So here's another question. I'm not sure. It may be more for Shacha, but let's see. Because it could be interpreted about Warp or about maybe Cairo and Starknet. What do you intend to do to speed up applications?
Yeah, I think that's a question for Shahar.
Yeah, that's a question for Shahar. Yeah. I assume you mean speed up things on Starknet. Well, there are a lot of aspects to what speed up can mean. Uh, as for scaling on Ethereum, is the more people use Starknet, the more efficient it will become regarding L1 costs. But another aspect in the current version of Starknet is not that fast, is basically just the sequencers. And remember that Starknet is only in alpha phase still. It's not decentralized, and we have a sequencer which is used mainly for, you know, uh, getting used to the system, seeing how things work together, developing on it. But once it reaches a more mature phase and decentralized, then everything could be a lot faster. People will have large machines and run their things. We could have L3s on top of it and make it even faster. Once the full node implementations and the sequencers from developers which are working on it right now come to life, then everything should be a lot faster uh, in this sense. But it's not that. I mean, it's not now, but it's not a theoretical challenge to run things fast on your local machine, uh, or in any one machine, which is what is required right now. Once we go past the alpha phase, uh, and when this gets done, then we would be able to scale like a lot. And L1 won't be the bottleneck. I hope I answered the question.
Next question, which I think is also to Shachar, but I'll also venture to say something about it. How does Stark see app scaling at such a slow rate as it is today? So I think this is about probably the rate of transactions or something on the testnet. I want to say that doing what we're attempting to do, which is to validity prove general computations in a very efficient way, is a pretty challenging thing. And I mean, folks like Shachar and everyone on our team are working very hard, but it's a grand challenge. So I mean, the thing, I mean, we focused so far was on usability. The next phase that we're just about to start is related to throughput and performance on Starknet. I remind you that we're very optimistic, and one of the reasons is that we already have systems, basically the StarkX systems, on DYDX and Immutable, and that are running at TPSs of basically any demand that was thrown at them so far. They sort of gobbled up very nicely. And so there, the scale and the throughput and everything is really, really good. And part of what happened with Starknet, Shachar, I'll let you explain more about this, but we basically took that sort of engine and we brought it over as quickly as possible. And then there are many things there that are not, as performant for a general purpose Starknet system as they are for those systems. So we're aware of that, and that's going to be the next phase. It's going to last till roughly the summer. I hope people will bear with us and be willing to tolerate this. Shachar, what do you want to say about the rate and speed on Starknet?
Yeah, I mean, there are even things we're doing right now to make everything faster. Whether it's the response time of our API, and whether it's just executing all the transactions, which currently run sequentially on a single sequencer, because that is just the minimal viable product for testability, for usability we had. So there are efforts right now to parallelize these executions, and this should see even now a lot of benefit before the next phase.
Okay, I think we're going to take 3 more questions, and these questions I think are all of them to the Warp team. The first one I think it says that in 2022 there will be transitions from Solidity to Warp. I guess I interpret that as asking, do you think that in 2022 you'll see, and I'm going to combine it with the next question. I think it's roughly the same thing. When do you expect Warp 2.0 to be production ready? I think they're sort of asking the same thing, right? How usable?
Yeah, I think Warp 2.0 about a month and a half, 2 months. Yeah.
So it's usable then to
it's production ready.
is still auditing and verifying.
Yeah. We need to go through an audit first before we can say, hey guys, it's production ready. But when it will be ready to be audited is in about a month and a half, 2 months.
Okay. Next question, and then one more, and then basically I'll let you just wrap it up. Will there be a formally verified transpiler eventually, or at least a formally proved one, similar to the lean proof for Cairo VM?
Yeah, so we formally specified YOL with the goal of eventually verifying Warp, but we changed to Solidity. And the problem with trying to do it with something like Solidity is that these formal specifications and proofs are like very, very sensitive to changes somewhere else. So if like Solidity changes the semantics of a certain language feature or changes the language feature, it could break the entire specification and verification. And just specifying something like Solidity is like an 8-month to a year probably effort in and of itself. So at the moment, we're not thinking about formally verifying Warp 2.0.
Okay, so last question. Why should new developers partner with you?
Partner with them? I think that's to Starknet.
Yeah, then Shachar, yeah. You're muted, by the way.
Yeah. If you want to scale your app, then you should work with us. If you don't, then don't. That's
good on.
I like that. Yeah. If you want to reach scale, yes, I agree. Okay, so I mean, Shachar, since you're on the screen, maybe final words, and then final words by Yorik and Greg.
Yeah, I think the Warp project is a real leap forward and step in the maturity of Starknet. A lot of contracts are written in Solidity, and a lot of programmers know Solidity. A lot of projects that can be very big a core base for other stuff. So I think it's very exciting that this is finally complete.
Thanks, appreciate it. And I'll just do a bit of a shameless plug for our pitch. So Nethermind is hiring like crazy across all our teams. So Warp, formal verification, auditing, we've got a bunch of roles open, and so have a look at our job board and maybe you'll find something interesting there.
Okay, so basically I want to thank Yorik and Greg from Nethermind. Sorry for squeezing you in, and Shachar from Starkware. It's been a terrific Stark at Home episode. It's going to be, I mean, all these episodes are recorded. We hope to see a lot of you on future things, and more importantly, go press the button which will bring you to the Warp GitHub. Get yourself warped into Starknet and start scaling. Thank you very much.
Thank you. Thanks for having us.
Thank you.
Bye.
Bye.
Bye.